Hello there, and welcome to Worlds Beyond Seen, where quiet curiosity meets the edges of what we think we know, and where questions linger longer than answers. Tonight, we're not looking up at the stars or out into the black expanse of space. Instead, we're turning our gaze inward, toward our own planet, toward the familiar ground beneath our feet, and asking something that sounds simple but unravels into complexity with every word. What if we're not alone in our own history? Not aliens from distant galaxies, not visitors from other dimensions, but something closer, something stranger. What if, somewhere in the isolated corners of this world, another civilization rose alongside ours, developed in parallel, built cities and cultures and knowledge, and then vanished so completely that we never knew they existed at all? A twin civilization, hidden not by distance in space, but by distance in time, by geography, by the slow grinding of geological forces that erase and bury and forget. Before we begin this journey into the possibility of the unknown, I invite you to like the video and subscribe to the channel to receive more stories that explore the mysteries of our world. Your support helps us continue bringing these thoughtful explorations to listeners like you who appreciate taking the time to wonder. Now, settle in. Maybe you're listening as the day winds down, or perhaps in the quiet hours when the world feels larger and more mysterious. Either way, let's walk together through this question, slowly, carefully, examining what we know, what we've found, and what remains hidden in the shadows of deep time and distant places. The question that won't go away. We like to think we know our planet's story. We've drawn timelines, built museums, written textbooks. Human civilization, we're told, begins around 10,000 to 12,000 years ago, with the dawn of agriculture in the Fertile Crescent. Before that, scattered hunter-gatherer groups, cave paintings, stone tools, simple, linear, clean. But the Earth is 4.5 billion years old. Life has existed for over 3 billion of those years. Complex multicellular life has flourished for hundreds of millions of years. And humans, in our current form, have walked this planet for perhaps 300,000 years. In that vast sweep of time, in those endless millennia, is it really so impossible that intelligence emerged more than once, that complexity arose, flourished, and faded away before we ever arrived to notice? The conventional view says yes, it's impossible, or at least extraordinarily unlikely. We'd have found something, the argument goes. Cities don't just disappear. Stone doesn't lie. If another civilization had existed, especially one advanced enough to be called a parallel society, we'd have stumbled across their remnants by now. But would we? Really? Consider this. Most of the archaeological sites we've discovered were found by accident. A farmer ploughing a field in China unearthed the terracotta warriors. A shepherd boy in the Judean desert stumbled upon the Dead Sea Scrolls. Construction workers in Mexico City revealed the Templo Mayor of the Aztecs. We find things when we're looking in the right place, at the right time, often for completely unrelated reasons. Now consider what we haven't looked at. The ocean floor, which covers 71% of the planet's surface, remains largely unexplored and unmapped. We know more about the surface of Mars than we do about the deepest parts of our own oceans. Beneath Antarctica's ice sheets, miles thick in places, lie landscapes we've never seen with human eyes. The Amazon rainforest, the Congo basin, the depths of the Sahara sand before it was desert. All these places hide secrets beneath layers of time and transformation. And geological time is not gentle. It doesn't preserve. It recycles. Tectonic plates slide beneath one another in subduction zones, dragging entire seafloors back into the mantle where they melt and become magma again. Mountains rise and erode to nothing. Coastlines shift. Forests become deserts, become oceans, become land again. In the span of millions of years, the Earth's surface is completely rewritten. Every trace of what once was either buried beyond reach or ground into molecular dust. So the question remains, hanging in the air like morning mist, not whether a parallel civilization existed, because we don't know that, but whether we'd recognize the evidence if it did, whether we're even asking the right questions. Whether our assumptions about what civilization looks like might be blinding us to possibilities we haven't imagined. What makes a civilization? Before we search for a lost civilization, we should probably agree on what we're looking for. The word civilization gets thrown around casually, but it carries weight. It implies a certain threshold of complexity, organization, permanence. In traditional archaeology, civilizations are identified by specific markers, urban centers, where populations gather in concentrations beyond simple villages. Specialized labor, where not everyone is a farmer or hunter, but some people craft tools, others build, others govern, others create art or maintain religious practices. Monumental architecture, structures built not for mere survival but for display, worship, memory, writing systems, methods of recording and transmitting information across time and space, social stratification, hierarchies of power and status, long-distance trade networks, exchange of goods and ideas across regions. But this definition is distinctly modern, shaped by the civilizations we know: Egypt, Mesopotamia, the Indus Valley, China, Mesoamerica. What if a civilization didn't fit this mold? What if it organized differently, left different traces, valued different achievements? Consider the Göbekli Tepe in Turkey, discovered in 1994. Massive stone pillars, intricately carved, arranged in circles, built around 11,600 years ago, predating agriculture, predating settled villages as we understand them. The people who built Göbekli Tepe were, by conventional archaeological wisdom, supposed to be simple hunter-gatherers. Yet they coordinated labor on a scale requiring hundreds of people, transported stones weighing many tons, carved elaborate artwork depicting animals and abstract symbols. They built not homes but what appears to be a ceremonial center. And then, after using it for perhaps 1,000 years, they buried it deliberately, filling the structures with rubble and soil, preserving them for millennia until modern excavation brought them back to light. Göbekli Tepe challenges our assumptions. It suggests that monumental construction might have preceded settlement rather than followed it. That ritual and belief might have driven social organization before agriculture or cities did. That complexity can take forms we don't expect. So when we ask about a parallel civilization, we're not necessarily looking for pyramids and palaces. We're looking for evidence of sustained, organized complexity, deliberate modification of the environment, transmission of knowledge across generations, coordinated efforts that transcend individual survival. These might manifest in ways familiar to us or in ways we've never imagined. And that's part of the challenge. We know how to recognize what we've already seen, but recognizing something genuinely different, that requires imagination, flexibility, and a willingness to question our own frameworks. The geography of isolation. If a parallel civilization existed without our knowledge, where might it have been? The answer lies in isolation, in places so remote or so transformed that their secrets remain locked away. Let's start with the most obvious candidate, Antarctica. Today, Antarctica is a frozen wasteland, hostile to complex life, buried beneath ice sheets, averaging 1.6 miles thick. But Antarctica hasn't always been frozen. As part of the ancient supercontinent Gondwana, it once sat at much warmer latitudes. Geological evidence shows that between 90 and 40 million years ago, Antarctica had a temperate to subtropical climate, with forests, rivers, and diverse ecosystems. Even more recently, during the Eocene epoch around 50 million years ago, temperatures were warm enough that palm trees grew near the poles. And some ice core data suggests that portions of Antarctica might have been ice-free as recently as 5,000 to 10,000 years ago, though this remains controversial among glaciologists. If humans or pre-human hominids existed during a warm period on Antarctica, any evidence would now be buried beneath miles of ice, compressed, possibly destroyed by glacial movement, accessible only through expensive, difficult drilling operations in one of the most inhospitable environments on Earth. Ground-penetrating radar has revealed subglacial lakes, mountain ranges, and ancient river systems beneath the ice. Lake Vostok, buried under more than 2 miles of ice, has been isolated from the surface for at least 15 million years. It's a sealed ecosystem, potentially harboring unique microbial life. Could such isolated, protected environments also harbor archaeological secrets? Possibly. But we haven't looked. Not really. The Antarctic Treaty restricts extensive excavation, and the technical challenges are immense. Then there's the Sahara Desert. Today it's the world's largest hot desert, an endless expanse of sand and rock, but the Sahara hasn't always been desert. The African humid period, which occurred roughly between 11,000 and 5,000 years ago, saw the Sahara transform into a verdant landscape of grasslands, lakes, and rivers. Archaeological evidence shows that people lived there, hunted game, fished in now-vanished lakes, created rock art depicting giraffes and hippos and cattle in regions that are now utterly barren. Before the African humid period, there were earlier wet phases. The Sahara oscillates between desert and grassland on cycles of approximately 20,000 years, driven by changes in Earth's orbital parameters and the precession of the equinoxes. During wetter periods, the region could have supported substantial populations, but when the climate shifted and the desert returned, it buried everything. Sand dunes migrate, covering and uncovering landscapes. Wind erosion scours away evidence. What lies beneath the sand? We've barely scratched the surface. In 2000, satellite imaging revealed evidence of ancient river systems beneath the Sahara, networks of channels that once carried water across what is now sand. Ground-penetrating radar has detected structures buried beneath dunes, possible settlements from periods when the climate was different. But accessing these sites, excavating through meters of sand in extreme heat, presents enormous challenges. Most of what might be there remains unexplored. The Amazon rainforest presents a different kind of hiding place. For decades, the prevailing view was that the Amazon was essentially pristine wilderness, too harsh and resource-poor to support large populations. But that view has been shattered by recent discoveries. LiDAR technology, which uses laser pulses to map terrain beneath dense vegetation, has revealed vast networks of earthworks, geometric patterns, roads, and what appear to be the foundations of settlements. In the Upano Valley of Ecuador, archaeologists discovered evidence of a civilization that thrived between 500 BCE and 600 CE, with urban planning, agricultural terraces, and populations potentially exceeding 100,000 people at their peak. These weren't small villages, they were substantial settlements, organized and sophisticated, hidden beneath jungle canopy until modern technology allowed us to see through it. And this was just one small region. The Amazon basin covers approximately 2.7 million square miles. How much more lies beneath the trees, still undiscovered? The rainforest consumes structures rapidly. Wood rots, stones are overgrown, even metal corrodes in the humidity. Without the distinctive earthworks or the luck of LiDAR surveys, settlements could remain invisible for centuries more. Underwater sites offer perhaps the greatest opportunity for hidden civilizations. During the last glacial maximum, approximately 20,000 years ago, sea levels were roughly 400 feet lower than today. Vast expanses of what is now continental shelf were dry land. The Bering Land Bridge connected Asia to North America. Sunderland united much of Southeast Asia into a single landmass. Doggerland stretched between Britain and continental Europe. These weren't marginal environments. They were productive coastal plains, with rivers, forests, and abundant resources. They would have been attractive places for human settlement, and when the glaciers melted and sea levels rose, these landscapes were inundated. Any settlements built there now rest beneath hundreds of feet of water and sediment, inaccessible except through expensive underwater archaeology. We found a few examples. The submerged city of Pavlopetri off the coast of Greece dates to around 5,000 years ago. Dwarka, off the coast of India, may be even older, though dating remains controversial. The Yonaguni Monument in Japan, discovered in 1986, features what some argue are carved steps and terraces, though others contend it's a natural formation. These discoveries are rare, representing a tiny fraction of the submerged landscape. Most of the drowned world remains unexplored, its secrets sealed beneath sand and silt. The Silurian hypothesis, a thought experiment. In 2018, two scientists published a paper that captured the imagination of anyone who'd ever wondered about deep time. Astrophysicist Adam Frank and climate scientist Gavin Schmidt proposed what they called the Silurian hypothesis, named after a fictional race of intelligent reptiles from the British science fiction series Doctor Who. The hypothesis wasn't claiming that such a civilization existed. Rather, it asked a methodological question. If an industrial civilization had existed on Earth tens or hundreds of millions of years ago, how would we detect it? What traces would survive? And could we distinguish them from natural processes? Frank and Schmidt started with the observation that humans have only been in our current form for about 300,000 years, and we've only had industrial technology for about 200 years. In geological terms, that's not even a blink. It's a razor-thin slice of time. If all of human civilization vanished tomorrow, what would remain in 1,000,000 years? 10 million? 100 million? Most of our buildings and infrastructure would decay relatively quickly. Steel corrodes, concrete crumbles, plastics break down. Within thousands of years, even the most imposing structures would be reduced to rubble. Within tens of thousands of years, most above-ground traces would be gone. But what might persist? Certain chemical signatures could endure. The burning of fossil fuels changes the ratio of carbon isotopes in the atmosphere. This shift gets recorded in sediment layers and ice cores. If we suddenly burned enormous quantities of carbon, that spike would show up as an anomaly in the geological record. Similarly, industrial activity produces synthetic compounds, rare earth elements, and isotope ratios that don't occur naturally. Nuclear technology leaves its own fingerprints. Plutonium-244 doesn't exist in nature outside of supernovae. If you found it in the geological record, it would almost certainly indicate technological activity. Similarly, certain other transuranic elements and specific patterns of radioactive decay could point to nuclear reactors or weapons. Mass extinctions provide another potential marker. Humans are currently driving what some biologists call the sixth mass extinction, with species disappearing at rates far above the background level. This biodiversity crash, if it continues, would show up in the fossil record as a sudden decline in the variety of life. If such a decline coincided with chemical anomalies and synthetic compounds, it might suggest an industrial civilization. But here's the challenge. Many of these signatures can also be produced by natural processes. Volcanic eruptions release enormous amounts of carbon. Asteroid impacts cause mass extinctions. Certain geological formations concentrate rare elements. Natural uranium deposits can even form what look like primitive nuclear reactors, as happened at Oklo in Gabon about 2 billion years ago. So detecting an ancient industrial civilization wouldn't be straightforward. You'd need multiple lines of evidence, all appearing together in a narrow geological time slice, forming a pattern that natural processes alone couldn't explain. And even then, interpretation would be difficult. Frank and Schmidt also noted that the best place to look for such evidence might not be on Earth at all, but on the Moon or Mars. These bodies have no plate tectonics, no weathering, no biology to consume and recycle materials. Artifacts left there billions of years ago might still be sitting on the surface, waiting to be found. The Silurian hypothesis forces us to confront an uncomfortable truth. The absence of evidence is not evidence of absence. Just because we haven't found something doesn't mean it isn't there. It might mean we're not looking in the right place, or we don't recognize what we're seeing, or geological processes have erased what once was. Artifacts that don't fit. Over the years, various objects have been reported that seem to challenge our understanding of history. Often called out-of-place artifacts or OO parts, these are items that appear in contexts that don't make sense according to conventional chronology. The Antikythera mechanism is perhaps the most famous example. Discovered in a shipwreck off the Greek island of Antikythera in 1901, This device dates to around 100 BCE. It's an intricate assemblage of bronze gears and dials, far more sophisticated than any other known artifact from the ancient world. For decades, its purpose was a mystery. Modern research using X-ray tomography and careful reconstruction has revealed that the Antikythera mechanism was a mechanical computer designed to predict astronomical phenomena, including the positions of the sun, moon, and planets, as well as lunar and solar eclipses. It represents a level of mechanical precision and astronomical knowledge that historians previously didn't think existed until more than 1,000 years later. The mechanism doesn't suggest a parallel civilization. We know ancient Greeks built it, but it does demonstrate that our assumptions about technological capability can be wrong. If one society could build something so advanced and have it be almost entirely lost to history, what else might have existed that we don't know about? The Baghdad Battery is another intriguing case. Discovered near Baghdad in 1936, these terracotta jars, dated to around 200 BCE to 200 CE, contain copper cylinders and iron rods. Some researchers have suggested they could have functioned as primitive galvanic cells, generating small electric currents if filled with an acidic liquid like vinegar or wine. The mainstream interpretation is that they were storage vessels for sacred scrolls, and the electrical generation hypothesis remains controversial. No ancient texts describe electrical experiments, and there's no clear evidence of what such devices would have been used for, but the possibility lingers, a reminder that ancient peoples might have understood more about natural phenomena than we give them credit for. The Piri Reis map, created in 1513 by Ottoman Admiral Piri Reis, shows remarkably accurate coastlines of South America and Africa. Some researchers have claimed it also depicts Antarctica free of ice, suggesting knowledge of the continent before it was covered. Mainstream historians attribute the map's accuracy to Piri Reis's compilation of earlier sources, including potentially pre-Columbian maps, and argue that the supposed Antarctic coastline is actually a misdrawn South American coast. Still, the debate continues. How did pre-modern cartographers achieve such accuracy without advanced surveying equipment? Did they preserve knowledge from even older sources? Or are we seeing patterns that aren't really there, wishful thinking imposed on ambiguous data? Other parts are less convincing. The Klerksdorp spheres, found in South African mines and supposedly billions of years old, turned out to be natural concretions, mineral formations created by geological processes. The so-called Koso artifact, once claimed to be a 500,000-year-old spark plug, was almost certainly a modern spark plug encased in quickly forming mineral deposits, not ancient rock. The lesson here is caution. Most parts have prosaic explanations. Natural processes can create surprisingly regular forms. Modern objects can become embedded in sediment through various means. Human error in dating or context can make ordinary artifacts seem extraordinary, but dismissing everything as mistaken or fraudulent might be equally unwise. The Antikythera mechanism was originally dismissed as too complex to be ancient. New discoveries regularly force us to revise our timelines of technological development. The key is rigorous analysis, multiple lines of evidence, and willingness to follow the data wherever it leads. The problem of preservation. One of the strongest arguments against ancient parallel civilizations is the preservation problem. If they existed, where are their remains? Why haven't we found clear evidence? The answer lies in understanding just how poor the geological record really is. Fossilization is extraordinarily rare. Most organisms that die decompose completely, leaving no trace. To become a fossil, an organism must be buried quickly, protected from scavengers and decay, infiltrated by minerals that replace organic material, and then survive millions of years without being destroyed by geological processes. The result is that the fossil record is incredibly spotty. We estimate that less than 1% of all species that ever lived are preserved as fossils, and of those fossils, only a tiny fraction have been discovered. Most remain buried in rock we'll never access, or have been destroyed by erosion, tectonic activity, or metamorphism. If fossils, which are literally pieces of living organisms, are so rare, how much rarer would artifacts be? Tools, structures, and cultural objects face even steeper odds. Metal corrodes, wood rots, stone can be dissolved or ground to dust, only under very specific conditions. Rapidly buried in an oxygen-free environment, protected from heat and pressure, can organic materials survive for thousands of years, let alone millions? Consider what we know about our own species. Humans have been around for 300,000 years. We have fossils and stone tools from much of that time, but the record is fragmentary. Entire populations are represented by a single jawbone or a handful of flint flakes. Vast periods of time are complete blanks. And that's for a species we know existed, whose remains we're actively looking for. Imagine trying to find evidence of a species we didn't even know to search for, whose remains might be compressed in sedimentary layers we haven't excavated, in regions we haven't explored, or destroyed entirely by the Earth's constant recycling. The planet's surface is always in motion. Tectonic plates shift, grinding against each other, creating mountains, triggering earthquakes and volcanic eruptions. Oceanic crust is continually created at mid-ocean ridges and destroyed at subduction zones, where one plate dives beneath another and melts back into the mantle. The average age of oceanic crust is only about 200 million years. Any seafloor older than that has been recycled. If a civilization existed near an ancient coastline, and that coastline later became oceanic crust, any evidence would now be at the bottom of a tectonic plate, kilometers deep, unreachable, destined to melt and become magma within a few 100 million years. Continental crust is older and more stable, but it's not immune to destruction. Erosion wears down mountains, rivers carve valleys, glaciers scrape continents bare, deserts bury landscapes under sand, forests overgrow ruins. Each process removes evidence, scattering it, grinding it, making it indistinguishable from the natural background. And then there's time itself. 1,000,000 years is unimaginably long from a human perspective. In geological terms, it's barely a moment. 10 million years? Easily enough time for entire mountain ranges to erode to hills. 100 million years? The map of the Earth would be unrecognizable. If a civilization existed 100 million years ago, very little would survive. Maybe some chemical anomalies in sediment cores, maybe synthetic compounds buried in stable geological formations. Maybe, if we're very lucky, structures sealed in just the right environment. But most likely, nothing at all. Complete erasure. This doesn't prove a parallel civilization existed, but it does mean that the absence of obvious evidence doesn't prove they didn't. Underwater mysteries. The ocean holds particular fascination for anyone searching for lost civilizations. Water preserves in ways land doesn't. Shipwrecks thousands of years old can be found with their cargoes intact. Sunken cities retain their basic structure, but the ocean also destroys. Salt water corrodes metal. Currents shift sand, burying and uncovering sites repeatedly. Marine organisms colonize structures, altering them beyond recognition. And most importantly, the ocean is vast and deep and largely unsurveyed. We've mapped less than 20% of the ocean floor in high resolution. The rest is known only from satellite measurements of the sea surface, which can infer the shape of the seabed from gravitational anomalies. But these are coarse maps, showing only the largest features. A city on the continental shelf might be visible. A scattered village probably wouldn't. And continental shelves are where we'd most expect to find evidence of ancient coastal settlements. During the last glacial maximum, these were productive lands, rich in resources, easy to inhabit. As sea levels rose, they were gradually inundated. The process wasn't catastrophic everywhere, but it was inexorable. Over thousands of years, the ocean claimed hundreds of thousands of square miles of formerly dry land. Some underwater sites have been discovered. Pavlopetri in Greece, dated to around 2800 BCE, is one of the oldest known submerged cities. The structures are recognizable, houses and streets and workshops, preserved by relatively gentle sedimentation. Dwarka off India's coast is more controversial. Carbon dating of artifacts suggests occupation around 7,500 BCE or earlier, which would make it one of the oldest known urban sites anywhere. But the structures are eroded and overgrown, making interpretation difficult. Some archaeologists question whether they're artificial at all, or just natural formations being read as ruins. The Yonaguni monument in Japan has sparked even more debate. Discovered by a dive tour operator in 1986, it's a massive stone structure with flat surfaces, right angles, and what appear to be carved steps. Some researchers argue it's the remains of an ancient city, possibly dating to a time when sea levels were much lower. Others insist it's a natural geological formation, shaped by regular rock fractures and erosion. The scientific consensus leans toward natural formation, but the debate continues. And regardless of what the Yonaguni monument is, it highlights a larger point. The ocean floor is full of structures and formations we don't fully understand. In 2012, researchers using sonar discovered a circular rock structure in the Sea of Galilee, about 30 feet below the surface. Made of basalt boulders, it's approximately 230 feet in diameter and estimated to weigh about 60,000 tons. Its age is unknown, but it appears to predate the rise of water in the area, meaning it was built on dry land and later submerged. Its purpose remains a mystery. Offshore from Cuba, sonar scans in 2001 revealed unusual formations at depths of around 2,000 feet. The researchers described geometrical shapes that could be interpreted as urban structures, including what looked like pyramids, roads, and buildings. But at such depth, deploying equipment for detailed investigation is prohibitively expensive. Follow-up expeditions have been limited, and the site remains largely unexplored. These discoveries, whether proven to be natural or artificial, represent a tiny fraction of the submerged landscape. Most of the ocean floor has never been seen by human eyes or scanned by modern equipment. Entire civilizations could rest beneath the waves, unknown and undiscovered. And it's not just coastal areas. The Mediterranean Sea has been proposed as the site of various legendary civilizations, including Atlantis. The Black Sea saw a rapid rise in water level around 7,600 years ago when rising Mediterranean waters breached the Bosphorus Strait, flooding what had been a massive freshwater lake. Some researchers have suggested this event could be the basis for flood myths in the region. The Persian Gulf was largely dry land during the last glacial maximum, with the Tigris and Euphrates rivers flowing through it. As sea levels rose, the Gulf flooded, submerging any settlements that might have existed there. Some archaeologists have proposed that this flooding could have displaced populations that went on to found the early Mesopotamian civilizations, but proving any of this requires underwater archaeology, which is expensive, technically challenging, and often hampered by poor visibility, strong currents, and shifting sediments. Most underwater sites are discovered by accident, by divers, fishermen, or sonar operators looking for something else entirely. The Amazon's hidden cities. For most of the 20th century, the Amazon rainforest was assumed to be relatively untouched by human civilization. The prevailing theory, promoted by anthropologist Betty Meggers in the 1950 seconds, held that the poor soil quality and lack of large game made the Amazon unsuitable for dense populations or complex societies. Any people living there would have been small, scattered groups, leaving minimal impact. This view has been systematically demolished by recent discoveries. The Amazon was not pristine wilderness. It was a heavily managed landscape, shaped by indigenous peoples over thousands of years. Evidence of this management is everywhere once you know what to look for. Large areas of the Amazon contain terra preta, black earth, a highly fertile soil enriched with charcoal, bone, pottery shards, and organic matter. These aren't natural soils. They were created deliberately by pre-Columbian peoples, using techniques that researchers are still trying to fully understand. Terra preta can be several meters deep and remains fertile today, centuries after it was created. The presence of terra preta indicates long-term settlement and sophisticated land management. You don't create soil like this by accident. It requires sustained occupation, intentional composting and burning, and knowledge passed down across generations. And the extent of terra preta is staggering. Surveys suggest it covers up to 10% of the Amazon basin, an area roughly the size of France. That implies populations and activity on a scale completely inconsistent with the pristine wilderness model. But the real revelation came with LiDAR technology. Beginning in the 2000s, researchers started using aircraft-mounted laser systems to map the Amazon beneath its dense canopy. What they found was astonishing. In the Upano Valley of Ecuador, LiDAR revealed a network of settlements covering more than 1,000 square miles, with over 6,000 earthen mounds, roads, plazas, and drainage systems. The settlements date to between 500 BCE and 600 CE and may have supported populations exceeding 100,000 people. This wasn't a single city. It was an interconnected urban network with planned layouts, agricultural terraces, and sophisticated water management. The structures were hidden beneath jungle that, to the naked eye, looks like untouched rainforest. Without LiDAR, they would have remained undiscovered. Similar discoveries have been made across the Amazon. In Brazil's Acre state, researchers found evidence of hundreds of geoglyphs, massive geometric earthworks created by removing vegetation and soil. Some are circular, some square, some complex combinations of shapes. They're visible from the air but had been completely hidden by forest. Carbon dating suggests these earthworks are between 2,000 and 650 years old. Their purpose is unclear. They don't appear to be defensive structures, as they lack walls or fortifications. They might have been ceremonial sites, gathering places, or astronomical markers. Whatever their function, creating them required coordinated labor and planning. In Bolivia, near the city of Trinidad, researchers discovered an extensive pre-Columbian landscape modification. Networks of canals, raised fields, and causeways suggest intensive agriculture and water management. The system might have supported populations in the tens of thousands. These Amazonian civilizations had no writing system that we've discovered, no stone monuments, no metal tools beyond simple implements. They built with earth and wood and plant materials, and when they collapsed, likely due to diseases introduced by European contact, the forest reclaimed their settlements within decades. If we hadn't had LiDAR technology, if we hadn't thought to look beneath the canopy, we might never have known these civilizations existed. And the Amazon is huge. The basin covers 2.7 million square miles. We've surveyed only a small fraction of it with LiDAR. What else might be hidden there, waiting to be found? Antarctica, the frozen unknown. Antarctica occupies a unique place in speculation about lost civilizations. It's remote, hostile, and almost entirely unexplored beneath its ice. It's also a continent with a complex geological history, one that includes periods of much warmer climate. About 170 million years ago, Antarctica was part of Gondwana, positioned much farther north and enjoying temperate to subtropical conditions. Forests covered the land, dinosaurs roamed, rivers flowed. Even after Gondwana began breaking apart around 180 million years ago, Antarctica remained relatively warm. Fossil evidence shows that as recently as 50 million years ago, during the Eocene epoch, the continent supported forests of southern beech trees and other vegetation. The climate was similar to modern-day Patagonia or New Zealand. The cooling began around 34 million years ago. Changes in ocean currents, particularly the opening of the Drake Passage between Antarctica and South America, isolated the continent and allowed the Antarctic Circumpolar Current to form. This current blocked warmer waters from reaching Antarctica, leading to progressive cooling and the growth of ice sheets. By about 15 million years ago, Antarctica was heavily glaciated. By 5 million years ago, it had reached a state similar to today, with massive ice sheets covering virtually the entire continent. But some researchers have proposed that there might have been intermittent warm periods even more recently. Certain ice cores and sediment analyses have been interpreted as suggesting that parts of West Antarctica could have been ice-free as recently as 10,000 to 5,000 years ago, during a period of global warmth following the last ice age. This interpretation is highly controversial. Most glaciologists believe the ice has been continuous for millions of years, but if there were warm periods, even brief ones on geological timescales, they could have provided windows for life and potentially for habitation. Modern humans emerged in Africa around 300,000 years ago. If Antarctica had ice-free periods within the last few 100,000 years, is it possible that early humans reached it? In theory, yes. Humans were seafaring by at least 50,000 years ago, reaching Australia and various Pacific islands. A journey to Antarctica from the southern tip of South America would have been extremely difficult but not necessarily impossible. However, there's no evidence that such a journey ever occurred. No artifacts have been found on Antarctica suggesting pre-modern human presence. No legends or oral traditions from indigenous South American peoples speak of lands far to the south beyond the ice. But absence of evidence isn't evidence of absence, and most of Antarctica remains unexplored beneath the ice. The ice sheets that cover the continent are between 1 and 3 miles thick in most places. Ground-penetrating radar can see through ice to some extent, revealing the shape of the bedrock and detecting large structures like mountains and lakes, but it can't detect small features. An archaeological site, even a substantial one, would be invisible to current technology unless we knew exactly where to look. Subglacial lakes add another layer of intrigue. Lake Vostok, the largest, is about the size of Lake Ontario, buried under 2.5 miles of ice. It's been sealed off from the surface for at least 15 million years, possibly much longer. Other subglacial lakes have been discovered, some quite large. These lakes are isolated ecosystems. They receive no sunlight, have no connection to the outside world except through the ice above, and may harbour unique microbial life adapted to extreme conditions. They're scientific treasures, offering insights into extremophile biology and possibly analogues for life on icy moons like Europa or Enceladus. Could they also preserve archaeological evidence? In theory, if a civilization existed when parts of Antarctica were warmer and then the ice advanced, structures or artifacts could be encapsulated and preserved. The cold and isolation would protect them from decay, but accessing them would require drilling through miles of ice, an endeavour that's technically feasible but extraordinarily expensive and restricted by international treaty. The Antarctic Treaty, signed in 1959, designates Antarctica as a scientific preserve. Military activities are banned, mineral extraction is prohibited. Archaeological excavation would require special permits and international cooperation. The logistical challenges alone are daunting. The expense would be enormous, and without some compelling reason to believe something is there, funding such an expedition would be nearly impossible. So Antarctica remains a frozen question mark. Its ice hides landscapes we've never seen, geological formations we can barely map, and potential secrets we have no way of accessing. The continent could be entirely barren of archaeological interest, its cold too severe, its isolation too complete for ancient humans to have ever reached it. Or it could hold surprises that would rewrite what we think we know about human history. We simply don't know, and for now, we have no way to find out. Geological markers and chemical signatures. If a parallel civilization existed millions of years ago, the most durable traces wouldn't be buildings or artifacts. They'd be chemical signatures, subtle changes in the composition of rock and sediment that could persist for geological timescales. This is the insight behind the Silurian hypothesis. Instead of looking for tools or ruins, look for the impacts a civilization would have on its environment. Industrial activity leaves fingerprints, altered carbon ratios, synthetic compounds, isotope anomalies, changes in biodiversity. Let's start with carbon. The burning of fossil fuels releases carbon dioxide into the atmosphere, but this carbon has a particular isotopic signature. It's depleted in carbon-13 compared to atmospheric CO2. This is because the carbon in fossil fuels came from ancient plants, which preferentially took up carbon-1,2 during photosynthesis. When we burn coal, oil, and gas, we're releasing carbon-1,2 heavy CO2 into the air. This changes the ratio of carbon-1,3 to carbon-12 inches the atmosphere, and that change gets recorded in tree rings, ice cores, ocean sediments, and any other archive that captures atmospheric chemistry. This signature is so clear that scientists have proposed using it to mark the beginning of the Anthropocene, the proposed geological epoch defined by human impact. Starting around 1850 with the Industrial Revolution, the carbon isotope ratio shifts noticeably. It's a signal that should be detectable in the rock record millions of years from now. If another civilization burned fossil fuels, they would leave a similar signal. A sharp change in carbon isotope ratios, appearing globally in sediments from the same time period, would be hard to explain by natural processes alone. Volcanic eruptions release carbon, but the isotopic signature is different. Oceanic outgassing also releases carbon, but it's gradual, not sudden. A spike that's both sharp and global, appearing in multiple independent records, would be suggestive. Not proof, but suggestive. Similarly, industrial activity produces nitrogen compounds, particularly from fertilizer production and internal combustion engines. These nitrogen compounds alter the natural nitrogen cycle, and that alteration shows up as changes in nitrogen isotope ratios in sediments and ice cores. Plastics and synthetic polymers leave their own markers. These materials don't occur naturally, they're entirely artificial, created from petroleum through complex chemical processes. Microplastics are now found everywhere on Earth, from the deepest ocean trenches to the highest mountains, from polar ice to remote islands. These plastics will persist for tens of thousands of years, possibly longer. They break down into smaller and smaller fragments, but the molecules themselves are stable. Eventually they'll be buried in sediment, incorporated into sedimentary rock, and might survive as a distinct layer, a plastic horizon, marking the time when humans mass-produced synthetic polymers. If another civilization had developed similar materials, we might find strange organic compounds in ancient rocks, molecules that don't fit known biological or geological processes. They'd be rare, scattered, possibly altered by heat and pressure, but perhaps still detectable with modern analytical chemistry. Nuclear technology leaves perhaps the most unambiguous signature. Certain isotopes, like plutonium-244 or certain transuranic elements, don't occur naturally except in trace amounts from cosmic rays or supernovae. If you find them concentrated in a sediment layer, especially in association with other isotopes characteristic of fission reactions, it's hard to explain except through technology. The natural fission reactors at Oklo in Gabon, which operated about 2 billion years ago, show what's possible naturally. Uranium ore, under the right conditions of water saturation and concentration, can undergo sustained nuclear reactions. But these natural reactors produce specific isotope ratios different from artificial reactors. A trained nuclear chemist can distinguish them. So far, no one has reported finding evidence of ancient nuclear technology in the geological record. The isotopes we find are consistent with natural processes, but the search hasn't been exhaustive, and we might not recognize the signature if it was degraded or altered by subsequent geological events. Mass extinctions offer another potential marker. Human activity is currently driving species to extinction at rates far above the background level. If this continues, it will show up in the fossil record as a sudden decline in biodiversity, similar to the mass extinctions caused by asteroid impacts or volcanic eruptions. But mass extinctions have many causes. Identifying which were natural and which were caused by intelligence is tricky. You'd need to correlate the extinction with other markers, chemical anomalies, synthetic compounds, isotope shifts. The combination would be more convincing than any single piece of evidence. In practice, searching for these signatures is difficult. It requires drilling sediment cores from the deep ocean or stable lake beds, analyzing them with sophisticated instruments, looking for anomalies in data sets where natural variation is already high. It's expensive, time-consuming, and uncertain. And even if you found something unusual, interpreting it would be challenging. Natural processes can produce surprising results. Confirmation bias could lead researchers to see patterns that aren't there. Extraordinary claims require extraordinary evidence, and geological data is rarely unambiguous. But the possibility remains. Somewhere in the billions of tons of rock that make up Earth's crust, there might be layers that record events we don't understand, chemical signatures that don't fit our models, anomalies that point to intelligence operating in deep time. The challenge of recognition, perhaps the most fundamental obstacle to finding evidence of a parallel civilization, is recognizing what we're looking at. We know how to identify human artifacts because we know what humans make. We recognize stone tools because we've studied how stones are knapped. We recognize pottery because we understand ceramic technology. We recognize settlements because we know what houses and streets look like. But what if another civilization didn't make tools the way we do? What if they didn't build houses or streets? What if their technology was biological instead of mechanical, organic instead of mineral? What if they organized themselves in ways that don't leave traces we'd recognize? Consider termites. A termite mound is an extraordinary structure. It's a sophisticated piece of climate-controlled architecture with ventilation shafts, temperature regulation, fungus gardens, and nurseries. The colony that builds it is a superorganism, displaying coordinated behavior, division of labor, and transmission of information. In some ways, it's not so different from a human city. But if you didn't know what you were looking at, you might dismiss it as a pile of dirt. Natural geology can create strange formations. Without the living termites to make the connection obvious, identifying an ancient fossilized mound as artificial would be difficult. Now scale that up. Imagine a civilization that built with living materials, bioengineering structures instead of constructing them, trees shaped to grow in specific ways, vines cultivated into networks, organisms designed to perform functions. After that civilization vanished, their creations would decay and look like natural landscapes. Or imagine a civilization that was primarily nomadic, moving with seasons or resources, never building permanent structures. They might have sophisticated knowledge of astronomy, ecology, medicine, passed down through oral tradition and practical expertise. They might create art, music, stories, but they'd leave almost no archaeological footprint. Some stone tools, perhaps, fire hearths, middens of discarded shells or bones. To an archaeologist, they'd be indistinguishable from any other hunter-gatherer group. We also have to confront our own biases. Archaeological interpretation is shaped by the cultures and assumptions of archaeologists. For decades, researchers assumed that complex societies required agriculture, writing, and cities. Discoveries like Göbekli Tepe challenged that assumption, showing that monumental construction could precede agriculture and permanent settlement. Similarly, researchers once assumed that the Amazon couldn't support large populations because of poor soil. The discovery of terra preta and extensive earthworks proved that assumption wrong. Indigenous peoples had developed sophisticated methods of soil management and landscape engineering that outside observers didn't recognize because they were looking for the wrong things. How many other assumptions might we be making that blind us to evidence? We assume that advanced civilizations leave permanent traces, but permanence is a choice, not a necessity. We assume that technology means metal and machines, but technology is just the application of knowledge to solve problems. And there are many kinds of knowledge, many kinds of solutions. A civilization that lived in balance with its environment, that valued impermanence, that built with biodegradable materials, that passed knowledge orally rather than through writing, could be every bit as complex and sophisticated as our own, but it would be nearly invisible to archaeology. And if such a civilization existed millions of years ago, forget about finding it. The odds would be astronomical. We'd be looking for something we don't know how to recognize, in places we haven't searched, in forms we can't imagine. Myths and memories. Every culture has its flood myths. The biblical story of Noah is the most familiar to Western audiences, but it's far from unique. The Epic of Gilgamesh, one of the oldest known works of literature, describes a great flood that destroyed humanity. Hindu texts tell of Manu, who was warned by a fish god to build a boat before a catastrophic deluge. Chinese mythology speaks of Gunyu, who controlled the flooding of the Yellow River. Greek mythology has Deucalion and Pyrrha, who survived a flood sent by Zeus to destroy humanity. Norse mythology describes a flood that only one human survived. The Maori of New Zealand have stories of a great flood. Indigenous peoples of the Americas, from the Aztecs to the Inuit, tell of rising waters that consumed the world. These myths share common elements: a warning, a few survivors, the destruction of a previous world, the beginning of a new one. Are they just storytelling motifs, archetypes that emerge naturally from the human imagination? Or do they preserve memories of actual events? There were real floods. At the end of the last ice age, as glaciers melted and sea levels rose, coastal regions around the world were inundated. The process wasn't instantaneous, but it was significant. Over several thousand years, sea levels rose by about 400 feet. Vast expanses of coastal plain, places where people probably lived, were submerged. Some of this flooding might have been dramatic. The Black Sea flood hypothesis, proposed by marine geologists William Ryan and Walter Pittman, suggests that around 5,600 BCE, the Mediterranean Sea breached the Bosphorus Strait and flooded into the Black Sea, which had previously been a smaller freshwater lake. The inrushing water would have been catastrophic, potentially displacing large populations. The hypothesis is debated. Some geological evidence supports it, other evidence contradicts it, but the basic idea that regional floods could have been severe enough to generate lasting cultural memories is plausible. Oral traditions can be remarkably durable. Aboriginal Australians have stories that appear to describe geological events from more than 10,000 years ago, including the flooding of coastal areas and volcanic eruptions. These stories were preserved through thousands of years of oral transmission, passed from generation to generation with enough fidelity that they can be correlated with known geological events. If oral traditions can preserve memories for 10,000 years, what might they tell us about earlier periods? Could myths of lost civilizations, of Atlantis and Lemuria, and other vanished lands, preserve fragments of actual history? Plato's account of Atlantis, written around 360 BCE, describes an advanced civilization on an island beyond the Pillars of Hercules, presumably the Strait of Gibraltar. This civilization, Plato wrote, was destroyed in a single day and night of catastrophe, sinking beneath the waves. Most scholars consider Atlantis a philosophical allegory, a cautionary tale about hubris and the dangers of imperialistic expansion. But some researchers have speculated that Plato might have been drawing on older sources, perhaps Egyptian records that he encountered during his travels. Could Atlantis have been a real place? If so, where? Candidates have been proposed all over the world. Santorini in the Aegean, which was destroyed by a volcanic eruption around 1600 BCE. The Bimini Road in the Bahamas, a linear rock formation that some argue is an artificial structure. Even Antarctica, somehow flourishing before it froze. None of these candidates hold up to scrutiny. The Santorini eruption occurred long after the time Plato specified. The Bimini Road is almost certainly a natural formation. Antarctica hasn't been ice-free in millions of years, long before humans evolved. But the persistence of the Atlantis myth, and similar myths from other cultures, suggests something deeper, maybe not a memory of an actual place, but a collective recognition that civilizations are fragile, that what is built can be destroyed, that history is longer and more complex than any individual lifetime. The limits of what we know. One of the humbling aspects of modern science is recognizing how much we don't know. We've made extraordinary progress in understanding the universe, from the quantum scale to the cosmic, but vast territories remain unexplored, both literally and intellectually. Consider the ocean, covering 71% of Earth's surface, containing 97% of its water. The ocean is the planet's dominant feature. yet we've explored less than 20% of it in detail. The deep ocean, below about 650 feet, is almost entirely unknown. We've sent more people to the moon than to the deepest parts of the sea. Every deep-sea expedition discovers new species, new ecosystems, new geological formations. In 2000, scientists exploring the mid-Atlantic ridge discovered the Lost City hydrothermal field, a landscape of towering white carbonate structures unlike anything seen before. In 2012, filmmaker James Cameron descended to Challenger Deep, the deepest point in the ocean, and returned with images of a landscape that looked utterly alien. If we're still discovering entirely new ecosystems in Earth's oceans, what else might be down there? The continental shelves, now submerged, were inhabited land during ice ages. Most of that landscape has never been surveyed. Archaeological treasures, or simply evidence of how our ancestors lived, could be resting beneath silt and sand, waiting for someone to look. Antarctica is another vast unknown. The ice sheets hide an entire continent. Ground-penetrating radar gives us glimpses of the bedrock, revealing subglacial mountains, valleys, and lakes. But fine details are impossible to resolve. An archaeological site, even a large one, would be invisible unless we knew exactly where to drill. And even if we could survey beneath the ice, the Antarctic Treaty restricts activities on the continent. Mining is prohibited. Extensive excavation would require international agreement. The logistics would be nightmarish. The cost would be immense. Without compelling evidence that something is there, no one is going to fund the search. The Sahara Desert, the Amazon rainforest, the Australian outback, the Siberian taiga. All these regions contain areas that have never been surveyed in detail. Satellite imagery gives us overview, but it can't see through dense canopy or beneath sand. LiDAR is revealing hidden structures, but it's expensive and has been applied to only a tiny fraction of the planet. And that's just the surface. Beneath our feet, kilometers of rock hide geological secrets. Drilling is limited to specific locations where there's commercial interest, oil and gas exploration, geothermal energy, scientific curiosity. Most of the subsurface is completely unknown. Even our own recent past contains mysteries. Lost civilizations, not from millions of years ago, but from thousands. The Indus Valley Civilization, one of the largest ancient civilizations, flourished from about 3,300 to 1,300 BCE. Yet we still can't read their script. We don't know what language they spoke, what their cities were called, what their rulers were named. The Minoans of Crete, the Etruscans of Italy, the Olmecs and Zapotecs of Mesoamerica, all these cultures left substantial remains, yet much about them remains mysterious or unknown. If we struggle to fully understand civilizations from just a few thousand years ago, how can we be confident we haven't missed something from deeper time? The possibility of parallel development. Let's entertain the thought fully. Suppose a parallel civilization did exist, geographically isolated from the mainstream of human development. What would that look like? It might have started with a population that became separated during the great migrations of early humans out of Africa. Groups reached Southeast Asia, Australia, the Americas, following coastlines and island chains. Most of these populations eventually made contact with others, exchanging genes and ideas. But what if one group reached a remote location, an isolated continent or a chain of islands, and remained there, cut off, for tens of thousands of years? They would develop independently, creating their own technologies, their own cultures, their own solutions to the challenges of survival. In isolation, evolution takes different paths. This is why Australia has marsupials, while other continents have placental mammals. The ancestors of Australian mammals were isolated when the continent separated from Gondwana, and they evolved independently from the rest of the mammalian world. Cultural evolution works similarly. Without external influence, societies develop unique characteristics. The Aboriginal Australians, isolated for at least 50,000 years, created complex systems of knowledge and practice that differ fundamentally from Eurasian civilizations. Their technology, while adapted perfectly to their environment, didn't include metallurgy, writing, or large-scale agriculture. Does that make them less of a civilization? Not at all. They had rich oral traditions, sophisticated understanding of ecology and astronomy, intricate social structures, and artistic traditions that stretch back millennia. Their civilization was simply different, shaped by different circumstances and different choices. Now imagine a group that remained isolated even longer, in a place we haven't explored. They might develop knowledge we don't have, solve problems in ways we haven't imagined, or they might develop along familiar lines, inventing agriculture, metallurgy, writing, cities, all the markers we associate with civilization. And then something happened, perhaps a disease brought by the first contact with outsiders, perhaps climate change, making their homeland uninhabitable, perhaps internal collapse, social or environmental. They faded away, leaving their isolated homeland empty. If that homeland was Antarctica, it's now buried under ice. If it was a Pacific island chain, it might have been submerged by rising sea levels. If it was deep in the Amazon, the jungle has reclaimed it. If it was in the Sahara, the desert has buried it. No deliberate hiding. No conspiracy. Just the natural processes of time and geology doing what they always do. Erasing, covering, transforming. This scenario is speculative. Yes, there's no direct evidence for it. But is it impossible? No. Improbable? Perhaps. But in the vast sweep of human history, improbable things happen. The question is whether we'd recognize the evidence if it existed. The weight of unknowns. As we reach the end of this exploration, we're left not with answers, but with questions, with possibilities, with the recognition that our knowledge, however extensive, has limits. Have we found clear, irrefutable evidence of a parallel civilization? No. The artifacts that have been discovered, the geological anomalies, the submerged structures, all of these have plausible conventional explanations. None require invoking a lost civilization. But does the absence of clear evidence mean such a civilization couldn't have existed? Also no. The Earth is vast, largely unexplored in detail, and geologically active enough that evidence from the distant past is easily destroyed. We know our own civilization, for all its global reach and technological might, will leave only faint traces in the geological record if it vanishes. A few chemical signatures, some synthetic materials, possibly a thin layer of extinction and disruption. After 1 million years, even those might be ambiguous. If our civilization can be erased so easily, why couldn't another have been? One that never developed writing, never built with stone, never left the kinds of markers we look for. One that existed in a place we haven't searched, during a time we can't resolve? The answer is, it could have. We simply don't know. And perhaps that's the most honest conclusion. Not certainty either way, but acknowledgement of uncertainty. The recognition that history is deep, the Earth is old, and our understanding is incomplete. This isn't a call to believe in Atlantis or ancient astronauts. It's not an invitation to abandon rigorous science in favor of speculation. Rather, it's a reminder that science progresses by questioning, by challenging assumptions, by looking in places others haven't looked. The discovery of Göbekli Tepe changed our understanding of when monumental construction began. The Amazon earthworks changed our understanding of pre-Columbian populations. LiDAR technology is revealing structures that were invisible just decades ago. Who knows what the next decade, the next century, will reveal? Perhaps we'll find definitive evidence of a parallel civilization, structures or artifacts that can't be explained away, genetic or linguistic traces that point to isolated populations. Perhaps we'll develop new technologies that let us survey the ocean floor in detail, or drill through Antarctic ice to explore the bedrock beneath. Or perhaps we'll find nothing. Perhaps the Earth has been thoroughly surveyed, its secrets largely known, and no lost civilizations await discovery. Either way, the question has value. It pushes us to think bigger, to question our assumptions, to recognize that what we know is dwarfed by what we don't. A quiet conclusion. So here we are, at the end of this wandering path through possibility and evidence and speculation. We started with a question: what if Earth had a twin civilization we never discovered? And we've explored that question from many angles, looking at geology and archaeology, at the ocean and the ice, at chemical signatures and oral traditions. We haven't found proof. We haven't even found strong evidence. But we've found something perhaps more valuable: humility. The recognition that our planet is larger and older and stranger than we often remember. That history extends far beyond written records, beyond stone monuments, beyond anything we can easily access. The Earth keeps its secrets well. It buries, it erodes, it transforms. It's been doing this for billions of years, long before we arrived, and it will continue long after we're gone. Maybe there was another civilization, parallel to ours, isolated by geography or time or circumstance. Maybe they rose and fell in some remote corner of the world, leaving traces so faint we'll never find them. Maybe they're still there, hidden beneath ice or ocean or jungle, waiting for the right technology or the right question to bring them to light. Or maybe there wasn't. Maybe we are the only human civilization this planet has known. Maybe the story of human development is exactly as conventional archaeology describes it: a single lineage emerging from Africa, spreading across the globe, slowly developing agriculture and cities and writing. Both possibilities carry wonder. The first, that we might not be alone in our own history, that the Earth might hold secrets we can barely imagine. The second, that our civilization, for all its flaws, is unique, the only example of human complexity this planet has produced. Either way, the universe is vast, time is deep, and mystery remains. Rest well, traveller. Let these questions settle in your mind like silt in still water. There's no urgency to answer them. Some questions exist not to be answered, but to remind us how much we don't know, how much remains to be discovered, how much wonder still exists in the world. The search continues. Perhaps tomorrow, perhaps a century from now, we'll find something that changes everything, or perhaps we never will. But the searching itself, the questioning, the willingness to look beyond what we think we know, that's what keeps human curiosity alive. Sleep well. The Earth keeps spinning, the ice keeps its secrets, and the ocean covers its ancient shores. And somewhere, in the quiet places we haven't yet reached, the past waits patiently, neither revealing nor hiding, simply being. Until we're ready to look a little closer, ask a little harder, and accept that some mysteries might never yield their answers, no matter how long we search. Good night, and thank you for listening.